here working, and I had the game on, and they kept making Precal references, so I thought, I'll just give them a problem to do. So, this is the problem I gave them. Let's just make sure we can all do it. I just put the bones of it up here. We've got two functions, g and h. And we have a new function, f, that is g divided by h. And we want to know, where does f of x equal 1? So basically, don't we want 4 to the x plus 1 over 2 to the 3x to equal 1? Isn't that what we want?
Yeah.
So what are your thoughts on that? No calculator. This is no calculator.
Make 4 to 2x plus 2.
Get a common base.
Yeah.
So this is 2 squared. That's still okay.
Just do 2x plus 2 or 3x.
So 2 to the 2x plus 2 over 2 to the 3x equals 1. Now you got a couple different ways you can go. What would you like to do next?
I was gonna just take out the base. Should we do that?
No.
Wait, why not? Yeah, take out the 2. Did you throw
No,
it
stop
by
and
2
think, guys.
cancel
Wait a
out?
second. Stop. If you have a to the 7th over a to the 5th, is that just 7/5 or something? Do the a's just disappear? No, you still have a's left, right? So this is just like the a. So if you want to handle it like that, what would you do with these exponents? You don't divide the exponents, you subtract them. So could you subtract the exponents here? Yes. It might be easier if you multiplied this over here. Now, either way will work, okay? Guys, either way will work. But now, if you multiply this over to here, you have 2 to this power equal to 2 to this power. What does that automatically mean? The powers have to be equal, right? The powers have to be equal. So 2x plus 2 equals 3x. So the answer to the problem is 2. If you subtracted the exponents, which is perfectly fine, you would have 2 to what power? If you subtracted these, negative x plus 2, negative x plus 2 equal 1. 1 is a power of 2. What power of 2 is 1? 2 to the 0. So 2 to the negative x plus 2 equals 2 to the 0. Now I can set those equal to each other, and you see how I'll get the same answer? I think that way's a little trickier than just multiplying this over, but either way will work. Okay? All right, what did you find? What do we need to do? Multiple choice. Anna? 82. 82. And this is a calculator problem. All right, what is the value of S of 12? All right, so what have I got? S of t equals, and we know S of 4 is 3,000. Now, at first when I looked at this, Anna, my first instinct was, oh my gosh, this shouldn't be bad. All you do is plug in 12. Well, what's the problem with just plugging in 12? I don't know. Okay. So, that's why they gave me this. Because now I know that 300,000 is 500,000 over 1 plus 0.4 e to the 4k. Does that make sense to you? If I plug in 4 for my t, then the answer has to come out to be 300,000. That's a solvable equation. Now it's messy, but I have a calculator. So I'll bring this over, I'll multiply this over to here. So I have 300,000 plus, what's that times 0.4? 120,000, is that right? E to the 4K. And so I multiplied this over to here and did the distributed property. So that equals 500,000. Everybody with me? So then I can subtract that over, so I have 120,000 e to the 4K equals 20,000 or 200,000. Moving this guy over to the other side. Now I'll divide, so there go 4 zeros. So e to the 4K equals 20 over 12, which is 5/3. Everybody still with me? Now what am I gonna do? ln. So if I ln both sides, then 4K equals ln 5/3, and K equals ln 5/3 over 4. Now, Anna, I'm ready to do the problem. It was find S of 12. So now I'm just gonna plug 12 in. So it's gonna be 500,000. 1 plus 0.4 E to that, whatever that is, times 12. And I'm not gonna round off. I can type this in on my calculator and then use my answer button capabilities so I don't have any round off. So it should be 500,000. Oh wait, I gotta type that in first. Okay, and then 500,000 divided by parentheses 1 plus 0.4 E. I got 175, 324.6753. Hopefully that's an answer. Yeah, A.
Where do you get the 120,000?
When I multiply this, it's 300,000 times 0.4. I had to multiply this parentheses over here and then do the distributed property. All right, good. Yep, Emily?
Can you do 77?
77. By the way, that was a very good year. I graduated from high school that year. Yep, 77. In a certain situation, or a certain simulation, population can be modeled using a geometric sequence. The first day is day 1. The population on day 4 was 4,000. And the population on day 8 was 49,000. I need to find day 6. And it's a geometric sequence. What does that mean, to be a geometric sequence? We get from term to term to term by multiplying by something. So if you forget everything, you can figure this out because this is a sequence. So here's the first term, second term, third term. Fourth term is 4,000. Fifth, sixth, seventh, eighth term is 49,000. Does that make sense to you? this is the fourth term, this is the eighth term. Now, how am I getting from here to here to here to here? I'm multiplying by something, that's what geometric means. And the thing I'm multiplying by is the same. So, call it R or something, times R, times R, times R, times R. So 49,000 has to be what I get when I start with 4,000 and multiply by how many R's? 1, 2, 3, 4 R's? Does that make sense to you? So now I'll divide. So I have 49 over 4 equals R to the fourth. So I will 4 through both sides. Technically, that's going to be plus or minus, but not this time, because what do these values represent? The number of something, and it can't be negative, so I'm not going to worry about the negative. My R value is the 4 through the 49 fourths, which reduces to something, I'm sure. But I need this guy. So how am I going to get him? I'm going to start with that 4,000, and I'm going to times by 2 of those. So 4,000 times I got 14,000, is that right? So that is one way to do it, and I didn't need to really know anything except what it means to be geometric. Does that make sense to everybody? All right, anybody else has something that we need to look at? Yeah. 86. Okay, what do we mean by zeros? We mean the x-intercepts. So whatever we're finding the zeros of, we're going to set it equal to 0. Xander, are you doing the math?
Yeah.
Okay. Please make sure. All right, so there's F, and G is just that plus 0.05. And I need to know the zeros of that thing, so I'm just going to set that equal to 0. Is that okay? Does that seem right? Okay. Now, I have a calculator, so I'm going to go ahead and I'm going to sketch this thing. So I'm going to set up my window, and I'm going to go from 0 to pi. And this is a sine, so my y values don't have to be very big. Remember, sine maxes. Now I am adding a little bit here, but I might go from -2 to 2 on my y's. So I'm going from 0 to pi and -2 to 2. I'm going to type in this equation, sine parenthesis, sine 2.25x plus 0.2 close parentheses plus, is that 0.05? No, that's 0.5. Plus 0.5. Now remember, I graphed in the appropriate window, 0 to pi. How many times is across? Twice. So I can just do second calc zeros to find those. Remember how to do that? Second calc 0, or max, or min, or intersect, any of it. So one of them is 1.54. Oh, yep, that's one of them. And then I do the other one. And that one is 2.471. So it looks like C is the answer. Okay? Okay. Are we done? Did we do practice test 1, free response already? Yep, we're ready for practice test 2. Here we go. Let's get it out. I handed it out yesterday. Practice test 2. Here we go. So we're going to do a couple of these together. So I shouldn't see anybody on an iPad. We'll do free response. Start with free response. All right, anybody remember free response? What are the rules of the game? There's only 4 problems. 2 of them are calculator, 2 of them are not. And you have, they're done in separate sections, obviously, because you have a calculator and another calculator. You have 30 minutes each. So you have 30 minutes to do the 2 problems. So we are starting with the calculator. Number 1 is the calculator. 1 and 2. So we'll do 1 and 2 together, and then you guys can work on the other ones on your own. Okay, you have your answer sheet out? Okay, so we're going to get in the habit of using that, all right. So the figure shows the graph of an increasing function f, okay? On the graph, the function is given by this. Okay, so we have 2 functions given to us. One is a picture and one is an equation. We are going for part A, I. We are going to build the composition G of f of x. And we want to find h of 6. Okay, so what do we have to do first? F of 6. Now, f is the picture. So if you plug in 6, you get 3. So now we're finding g of 3 using the equation they gave us, which is, oops, 9 over, whoop, so guess what? Undefined. Can't do it. Undefined. Remember, never a 0 in the denominator. Find all the zeros of f, or indicate that there are no zeros. So f is your picture. It is an increasing function. So what does that mean? It's never coming down. So how many zeros does it have? 1, and its 0 is 3. All right, bi. Find all the x's for which g, which is 9 over x minus 3, equals negative 5.8. This is a calculator problem. Yep, this is a calculator problem. So let's make sure this is bi. Everybody okay with this? Okay, this is a little algebra 1. We can do this. So 9 equals negative 5.8x plus 17.4 maybe, is that right? Yeah. And then I'll subtract that over, so negative 8.4 equals negative 5.8x. I am getting 8.4 over 5.8, which when I type that into my calculator was 1.4483. How does that sound to you guys? whoops, I made a mistake.
When you subtract that 17.4, is that supposed to be negative 8.4 or positive?
Negative, wouldn't it be?
Oh, yeah.
But the negative ends up disappearing, because then I end up dividing by that negative. Don't let me get away with a mistake, guys. Thank you, Patrick, for being on top of that. Okay, all right, next. Determine the end behavior of G as X decreases without bound. Now, G is your equation. We need the limit as X approaches negative infinity. We're decreasing.
Would be two from the right,
Two.
the asymptote.
Well, this guy will have a vertical asymptote at 3. Would you agree with that? He'll have a horizontal asymptote at 0. How do I know that? As X gets bigger, doesn't that fraction get smaller? Okay. I wanna know what happens on this side. Well, one thing's for sure, I'm gonna come up like this, or I'm gonna come down like this, because that's what I do when I have a horizontal asymptote. I'm sitting here with a calculator. Could I graph it and look at it? Absolutely. Could I also plug in some points? Like, what happens if you put in negative 100? Won't that be a negative number? So at negative 100, it's a negative number. What's happening here?
It's
It's getting closer to 0 from the bottom. Nobody is standing over your shoulder saying, you've got to think about it this way. Think about it however it makes sense to you. Think about graphing it. Think about just plugging in numbers. Like negative 100, negative 1,000, negative 2 million. Plug them in, see what happens. Okay, I'm done with B. C. Is F, that's the picture, invertible? In other words, does it have an inverse that's a function? It's a yes or no question, guys. How many say yes? You are the right ones. You are the right ones. Why is it a yes?
You can flip that, so
You can flip it. It's 1 to 1. Look at your picture, you guys. Are there any Y's in the picture? Are there any Y's that are repeated? No. So when you do the inverse, what does that tell you about the X's? None of them will be repeated.
Do we just have to say it's 1 to 1?
Well, I is no, or I is yes.
Uh-huh.
And then give a reason for your answer based on the definition of a function and the graph. So I would, using the graph, I can tell by the graph that it's a 1-to-1 function. That means that no X's will repeat when I do an inverse. That kind of says you explain what a function is, that no X's repeat.
So inverse, like what is this inverse? Is it like across like the actual y-axis?
Identity, y equals X. Remember when you find an inverse, you switch X and Y.
Yeah.
So it flips across that.
Got it.
But the idea is, Xander, if we have an original picture, let's say this is my original, that is a function,
Yeah.
right?
Yeah.
But its inverse would not be a function,
Because
because you have two Y's that are being repeated, and when you flip those ordered pairs, then those things that were Y's now become X's, and X's can't repeat in function like that.
Yeah.
Okay, so 1 to 1 means no X's repeat, no Y's repeat. They don't want you using terminology about vertical line test and horizontal line test, but you can think about that for sure. If you pass both of those, you're 1 to 1. But don't say that, just say it's 1-1. That's the vocabulary they want. Okay, perfect. All right, well, I've talked enough. My plan was to do the first two, but I'm gonna let you have some time with your partner. Your homework tonight is the rest of the free response, okay? So you're gonna get the rest of the free response done. Okay, I'm trying not to overload you, but guys, we gotta practice,